Okay, so here's a question concerning ranking the strength of oxidizing and reducing agents. And so what I'm going to do is just going to grab this question and I'll put it somewhere where I can work on it so I can actually write on the screen. Okay, here we go. So here's our question, and it says, use the information in the Alex data tab to sort the following chemical species by reducing power. So we want to think of what reducing power means. So reducing power means that it's going to be tendency to give electrons, right? Okay, so because that's what it means to reduce something, it means to give electrons to the other thing. So it means what one likes, rank to be oxidized. Because if it's giving up electrons, that's what's happening. So whenever they're asking you about reducing power, or what is the most powerful reducing agent, or what is the best oxidizing agent, anything like that, you always want to be very, very confident to interpret the question. So which of these things likes to be oxidized the most? So how you're going to judge this is by looking up the standard reduction potentials. So I go into the Alex data and I look up the standard reduction potentials for all of these guys, and you can either copy and paste them over into a document, or you can just write them down on a scratch piece of paper, which is what I did, and you get all of the standard reduction potentials and you just kind of write them out, right? So there they all are, got another two to go. You see they're all written in the reduction direction. Okay, they're all written in the reduction direction. So we've always got electrons on the left. And then we got nickel 2 plus 2 electrons gives nickel, and then the value for that one minus 0.257. Now how the standard reduction potentials work is the more positive the value, the more likely it is that that reaction will occur. So what you see here is that we have the oxidized form of the species on the left, and we have the reduced form on the right of this equation. So what this is really saying is the more positive the standard reduction potential, the more it prefers the reduced form. Or another way of looking at it is the smaller or the more negative the standard reduction potential, the more it favors the oxidized form. And that's what we're looking for. So what we're trying to establish is we want to go from most negative, i.e. the one that likes the oxidized form the greatest, to most positive. So once you calmly kind of get your head organized as to what the question is asking, and then kind of relate it back to your standard reduction potentials, then you're in business. So we need to go from most negative to most positive. So it looks like the most negative one here is calcium, so that's going to be 1. Then the next one is nickel, so that's going to be 2. And then after that is silver, so that's going to be 3. And then finally it's a bromine or bromide. So we got to be, so that's, yes, that is correct. Okay, so that's it really. Let's see what happens when we put those numbers in. 3, 4, 1 and 2. 3, 4, 1 and 2. And we'll check that, and it's correct. And we're done.